So here's another opportunity to look at a step-by-step on how to graph a quadratic. You can look at the equation itself. As a reminder,
So here we are looking at the equation of a quadratic,
shape,
and so I'm going to go ahead and blow it up
and enough key points to know what we know.
Now, a reasonable sketch has the most difficult one key points, and if you know they have symmetry, and you know it's going to look like an upward facing, that we can pay attention to the fact that we know it's going to be an upward facing. You got to make sure that you're paying attention to the different parts and the different parabola equations that can tell you things. And we have learned some things about the different components of the equations and the different forms of the equation that can help us. So we're going to go ahead and look at those. For the key points of a parabola, you need that vertex, that lowest or highest point, and at least 2 points on each side, and then we can use the line of symmetry to graph the other side. So here we're going to do it in any order you want to do it. I'm going to go ahead and find the vertex first here, though, this time. And to find the vertex, you're going to want to find that line of symmetry first. So the first thing you have to do is identify the a, the b, and the c. The a is the number in front of x squared. Right now it is invisible 1. And then the b is a -4, and the c is going to be a 3. So we're going to go ahead and use that information first to find the vertex. We're going to use the vertex formula, and it's over here. The vertex formula says that we're going to go ahead and take the opposite of b. B right now is -4, so the opposite of b is +4. And then 2 times a, and a is 1. So the value of x is 4 divided by 2 times 1 is 4 divided by 2 is 2. So we know the x value is 2. We just need to know where the y value is. So we're going to go ahead and plug into the equation. If you have the factored form, you can use the factored form too, but whoops, I don't mean to do that. I meant to put in 2 there. And then do our math. 2 squared is 4. 4 minus 4 times 2 is -8, plus 3. And so you end up with 4 minus 8 is -4, plus 3 is -1. So when x is 2, y is -1. That's our vertex. And I'm going to go ahead and graph that. And the vertex is at 2, -1, right here. And because we know that a is 1, that means it's positive. And we're going to go ahead and know that the parabola faces up. So we can expect, now that we know that much information, we can expect visually, just imagine in your head, we've got some sort of upward, I'm just going to put it in a highlighter for a second, we've got some sort of upward facing parabola. That's what we know. And I'm going to go and erase that part and get the more specific information that we're going to get from the rest of the equation. So we know the vertex is at 2, -1. We're going to go ahead and look at the other things we know. If we have the equation, and here it is in standard form, the y-intercept is always going to be just that c value. And that's because if we plugged 0 in, we'd get 0 squared minus 4 times 0 plus 3. This part plus 3. This part zeroes out, leaving you just the 3. So whenever you have the standard form, you've got the y-intercept sitting there right in front of you. So you can go ahead and go back to our graph. And we're like, okay, so we know that the equation gives us a y-intercept there. And because we know that the axis of symmetry, I'm just going to draw this with a little yellow line here. The axis of symmetry goes right through that vertex. We can go ahead and know that it's going to look like that. And the last thing we have to do is just find the x-intercepts. Find the x-intercepts, or any point, any other point to make it on one side, so you have a really good sense of the shape. But the x-intercepts are pretty easy to find if you know how to factor, which you should by now. The factors here are the factors of 3, that are gonna give you sum of -4, so that works out to be -3 and -1. So the factors are x minus 3 and x minus 1. Since each of them then is set equal to 0, we get 3, and x minus 1 is equal to 0, and we get 1. So our x-intercepts are at 3 and 1. We head that back to our equation. Here's 1. Let's make sure I get the right pen. 1 and 3, and here we have our parabola. Reasonable sketch, way more work than a line or a whoops. Why did that happen? Huh. Yeah. I'm gonna leave that there. Not, no, huh. I don't know why that did that. I'm gonna be all fussy now. So we have our all of that stuff, and then our y-intercepts, and then we're going to go ahead and call it done. So it doesn't matter the order you do it. You can find the x-intercepts first, or you can find the y-intercept first, you can find the vertex first. I like to find the vertex first, because then I can see where the lowest or the highest point is. Or you can find the x-intercepts first and go into the middle and plug that number in. There's lots of ways you can do it, but you need to find those key pieces to go ahead and graph a quadratic. I asked you to practice again with this to see what the difference is. Well, here's our y-intercept. I'm going to do it in a different order this time. 1, 2, 3. Okay. Here's our factors. X plus 3. X plus 1. So that means our x-intercepts are at -3 and and -1. So here we go. I'm going to go ahead and put it -1 and -3. So once again, we've got our upward facing parabola. We just need that vertex, and the vertex is going to be right here. Don't have to use the formula now because I know that the vertex is going to be right here at -2 something. So I have to plug -2 into the equation. Plus 3, so I get 4 minus 8 plus 3. Again, I get -1. So here is the x squared plus 4x plus 3. That is exactly the same as the one on the previous screen, except it's flipped along the y-axis. It's rotated, it's reflected along the y-axis. So it has the same y-intercept, similar factors, opposite x-intercepts. So here we have a slope intercept form of a line. Remember, lines just need to have the correct shape. It's a line, and you need to pay attention to what. And people basically use two methods. One is to use the table to table. The y-intercept is right there at 0, -3, and then this one grows 2 for every 3. Okay, so we're going to go up 2 for every 3. So another point would be 3. -3 plus 2 is -1. And we could continue that process. It goes up 2. So this would be -1 plus 2 is 1, and this would be a 6. So I could go ahead and graph just those 3 points, and I have enough information to give me a quick, reasonable sketch. 0, -3, 1, 2, 3, -1, and then also 6, 1. We have a nice clean representation of y equals positive 2/3 x minus 1. By the way, lots of you also would just start at your, and I'm going to do this one in blue, start at the 0, -3, same y-intercept idea, but instead of using a table, the slope says to go up 2 over 3, up 2 over 3, and you get the same line, either method, slope triangle method, y-intercept, or make yourself a table, doesn't matter.
The other option, you don't have to learn both methods, is to graph using slope-intercept, y equals mx plus b, if you like to make your table. So that means you're going to want to get the y by itself and get it in the slope-intercept form, so you can recognize the slope and the y-intercept. We're going to get the y by itself. That means we're going to want to add 2x to both sides. These cancel each other out. All that's left on this side is the 3y. This side, the -9 and the 2x, pardon my bad drawing, are not like terms, so they cannot be combined, and there we have our 2x minus 9. We almost have it in slope-intercept form, but we are going to have to divide everything by 3. So every single term is going to be divided by 3, so you can write it this way as well. Divide this by 3. Divide this by 3, divide this by 3, and you end up with y equals 2/3 x minus 3, which is the exact same equation that we had originally in the y equals mx plus b form. So we can go ahead and sort of make it 3 and go up to over 3 and graph from there. So once again, you don't have to learn both methods, but it's good to have the strategies. The last reasonable sketch is an exponential one. We can tell this one's exponential because it has an initial value of 100, and then it's multiplying over and over and over again. Because of that, we know that this is our y-intercept. And so we're going to go ahead and put 100 here. Because it's multiplying by less than 1, so r is less than 1, that means we're going to have a downward facing curve. And it's never going to get to 0. And if we wanted to look at a quick table, we would have 0, 100, multiplying it by a half. I'm going to use a decimal. And then we'd end up with 150, and 225. And so remember that reasonable sketch is just going to have the correct shape. It's a curve. Correct direction downward because r is 1/2, and then your reasonable sketch is going to include two points on it, so in this case we'll just put the second, it's 225, and we're done.